Okay, this lesson is 4-5 out of your textbook, and it is covering the concept of completing the square. And one part of completing the square is using the square root property. So the first kind of examples that we're going to do are going to show you that if you can recognize what a PST is, PST stands for perfect square trinomial. It's when you have a squared plus or minus 2ab plus b squared. And it factors to, it's a perfect square trinomial. Try, got three terms. First term's a perfect square, last one's a perfect square, and it factors to this because a times b times 2 is going to be that middle term. And when you can do that and recognize your squares, then problems are a lot easier for you. And you'll be using them a lot when you get into conic sections and higher math classes. So first off, to look at this first example, x squared minus 12x plus 36 equals 25. And as I said, your inclination might be to subtract the 25. But if you recognize that this is a PST that factors to x minus 6 squared, then when you take the square root of both sides, so this is our PST here, then x minus 6 equals plus or minus 5, x equals 6 plus or minus 5, and x equals 6 plus 5. 6 plus 5 is 11, and 6 minus 5 is 1. Which, as you'll find out, sometimes is a little bit easier to solve things. So here, another perfect square. This is going to be x minus 8 quantity squared equals 49. When you take the square root of both sides, you're going to have x minus 8 equals plus or minus 7. X equals 8 plus or minus 7. So x equals 8 plus 7. Pooh, come back here. Go back. Okay, x equals 8 plus 7, which is 15, and 8 minus 7, which is 1. Okay, those were equations with rational roots. Now they want us to do some with irrational roots. But you will see, as I had a student say one time, kind of liking this completing the square property because it's a lot easier than dealing with the quadratic formula, especially when things don't factor. So this again is a PST. It's going to give us x plus 4 quantity squared equals 20. We get x plus 4 equals plus or minus the square root of 20, which is 2 square roots of 5. And then when we subtract our 4, then we get x equals negative 4 plus or minus 2 square roots of 5. And that, again, if you don't believe me yet, you would still be working the quadratic formula if that's what you were doing. Okay, last example like this. Again, another PST, x minus 3 squared equals 32. Take the square root of both sides, x minus 3, square root of 32. 32 is 16 times 2, so that's going to become 4 square roots of 2. And when you add 3, you get x equals 3 plus or minus 4 square roots of 2. And of course, that only works for you if you recognize a PST, or a perfect square trinomial. Okay, so let's talk about what's happening when we're actually completing the square on problems. Okay, to complete the square for any quadratic expression that is of this form, okay, you're going to find 1/2 of b, which is the coefficient of x, and then you're going to square it and add it to, well, it's got to be to both sides of the equation. So that's how they added it, and when they add it, that's how it factors to the other side. So let's go do some problems so you'll see how that works. And where am I? Let's go there. Okay, so first off, find the value of c that makes this a perfect square, then write the trinomial as a perfect square. So c is going to be equal to 1/2 of 14 quantity squared. Now, because you're squaring something, you can ignore the negative every single time. So 1/2 of 14 is 7. So what makes this a perfect square trinomial is if c is equal to 49. They want us to write it as a perfect square, so it would be x squared minus 14x plus 49. So those are the two answers to that question. All right, let's look at the next thing. It says, solve by completing the square. So when you complete the square, you got to go find that c value like we just did in the previous problem. So we set it up with blanks. And we've talked about this before, so this should be pretty easy for y'all. So x squared minus 10x plus blank equals negative 24 plus blank. Okay, good. And the next one. So we take half of 10, and I write it like this. Half of 10, 5 squared. 5 squared is 25. So I write that number half because then when you are going to, I'm going to go to yellow here. When you factor it, you're going to take this and this and this. And that is going to be your factor. So it's going to be x minus 5 quantity squared. Negative 24 plus 5 is 1. And then we proceed like we did in the previous problems. We take the square root of both sides. X minus 5 equals plus or minus 1. X equals 5 plus or minus 1. 5 plus 1 is 6, and 5 minus 1 is 4. Now, I do realize that some of y'all could have probably already factored that before I got that done, but this is a process that we're learning, okay? And sometimes things don't factor, as you're going to see in the next one, and why it's going to be easier to do it this way. I would only complete the square. It's just, let's put it this way, it's not fun to complete the square if b is not even. So we've got x squared plus 10x plus blank equals negative 9 plus blank. So you're starting off, you get your variables together, you get your number on the other side, 1/2 of 10 squared. And so that gives me x plus 5 quantity squared equals 16. X plus 5 equals plus or minus 4 because I took the square root of both sides, and x equals negative 5 plus or minus 4. So negative 5 plus 4 is negative 1. Negative 5 minus 4 is negative 9. Okay. Two more, no, more than two more, but anyway, let's look at these next two. All right, really important when a is not equal to 1, okay, because whenever you complete the square, a has to be 1 before you figure out what that c value is. So let's go, and what you're going to do, which in all honesty, okay, we're proving a point here, but in all honesty, I wouldn't complete the square if there's a problem. I'd use the quadratic formula, but it's a point, and let's make sure you know how to do it. So I'm going to, it's an equation. I have to divide everything by that a value. So that's going to give me x squared plus 10/3 x plus a blank. When I move the 8 over, it's positive 8, but it's been divided by 3. So that's what I have. 1/2 of 10 is 5/3. 5/3 squared is 25/9. Okay, then I factor. So if you write it like this, it makes your factoring much easier. So that's x plus 5/3 quantity squared equals 8/3 plus 25/9 is 49/9. And take the square root of both sides. X plus 5/3 equals plus or minus 7/3. And I will caution you, if I hadn't said it already, when you're completing the square and doing these problems, you do not want decimals, because you'll often find out when you get to this step, these two will have the common denominator, or it's much easier for you to take the square root of that without a calculator when it's a fraction versus being a decimal. Okay, so x equals negative 5/3 plus or minus 7/3. Negative 5 plus 7 is 2/3. And negative 5 minus 7 is negative 12/3, which becomes negative 4. All right, let's look at another one. No, let's go to that. Okay, 3x squared plus 14x minus 16. Again, we're going to divide everything by 3 because I can't complete the square if a is not 1. So I'm going to have x squared plus 14 thirds x plus blank equals, I'm taking the 16 to the other side, so that's 16 thirds plus blank. Half of 14 thirds is 7 thirds squared. 7 thirds squared is 49 over, not 4. Let's see how much, 49 over 9. Factor by taking x plus 7 thirds quantity squared. 16 thirds plus 49 ninths is 97 ninths. So when I take, this is the kind of thing, when you take the square root of these, you're going to get x plus 7 thirds equals plus or minus the square root of 97 over 3. So see, I've got the common denominator that I need to combine these two. Not that you have to, but anyway. All right, so x equals negative 7 thirds plus or minus the square root of 97 over 3. And you can leave it like that. If you want to write it all over the same denominator, you'll see that's what it would look like if it were coming out of the quadratic formula. All right, 2 more problems that we want to talk about, and that would be those that might have imaginary solutions. So, x squared plus 2x plus 2, same process. X squared plus 2x plus blank equals negative 2 plus blank. Half of 2 is 1 squared. 1 squared is 1. So this factors to x plus 1 quantity squared equals negative 1. When I take the square root of both sides, x plus 1 equals plus or minus the square root of negative 1 is I. And so x equals negative 1 plus or minus I. Make sure you put it in standard form. Okay, a plus bi. All right, last one. Let's go with that. I'm going to have x squared minus 6x plus blank equals negative 25 plus blank. Half of 6 is 3. You've got to square it, add it to both sides. X minus 3 squared. Negative 25 plus 9 is negative 16. So when I take the square root of both sides, I have x minus 3 equals plus or minus 4, and there's an I because I took the square root of a negative number. So x equals 3 plus or minus 4i. And that was lots of examples of completing the square. Hope you'll find it easy. Have fun. If you have any questions, please email me or let me know. Thank you very much.